The invisible battle happening inside every glass of water. It looks perfectly still, clear, calm, and harmless. But inside every glass of water, chemistry is constantly at war. Water feels simple because it surrounds us. We drink it, cook with it, and clean with it. Yet water is one of the most chemically active substances on Earth. It dissolves, transports, reacts, and reshapes everything it touches. Civilizations rise and fall based on how they control it. And that battle is happening right now, molecule by molecule. To understand why this matters today, we need to abandon the idea of purity. Water is almost never just water. The moment it exists in the real world, it begins interacting with air, with minerals, with containers, with living systems. Each interaction triggers reactions that never fully stop. Modern life depends on this behavior. Water delivers nutrients. It carries waste. It regulates temperature. It enables industry, agriculture, and energy. But the same chemistry that makes water useful also makes it dangerous. Because water does not choose sides. It reacts with everything equally. The first narrative beat begins with dissolution. Water molecules are polar. They pull charged particles apart. Salts separate. Metals leach. Gases dissolve. This ability makes water the universal solvent. But it also turns water into a carrier of conflict. Whatever it touches leaves a chemical trace behind. The second beat follows immediately. As substances dissolve, they change the water itself. pH shifts. Conductivity increases. Reactivity rises. What looks unchanged now behaves differently. The glass holds liquid, but the chemistry has already evolved. Then comes the third beat. Water reacts with its container. Metal ions migrate from pipes. Plastic molecules slowly escape from bottles. Even glass exchanges ions at the surface. Nothing is truly inert. The battle expands quietly. From the outside, the water remains calm. No color change. No movement. No warning. Yet inside, reactions compete for balance. Some stabilize. Others destabilize. Some protect. Others corrode. The system never rests. And this is where the story begins to turn. Because the invisible battle inside water does not stay contained. It moves into bodies, into machines, into ecosystems. And once it does, chemistry decides outcomes long before humans notice the consequences. Once water begins carrying dissolved substances, the battle intensifies. Every ion changes how water behaves. Calcium stiffens it. Sodium softens it. Chloride accelerates corrosion. Each addition rewrites the rules of reaction. At first, these changes feel insignificant. Water still flows. It still looks clear. But chemistry responds immediately. Electrical conductivity rises. Reaction pathways open. Water becomes an active participant, not a passive medium. This is where the story deepens. Because water does not just transport substances. It enables reactions between them. Dissolved ions meet. Electrons move. New compounds form. Scaling appears on pipes. Corrosion begins inside metal systems. The battle spreads beyond the glass. Inside living organisms, the conflict becomes more precise. Cells rely on water's chemistry for balance. Ion concentrations regulate nerve signals. pH controls enzyme shape. Small shifts alter biological outcomes. Water becomes a messenger carrying chemical instructions. When balance holds, systems function. When it slips, dysfunction follows. Modern water treatment tries to manage this chaos. Chlorine kills microbes. Fluoride alters mineral chemistry. Filtration removes particulates. Each intervention solves one problem while creating another. Water becomes engineered chemistry, not natural, not static, continuously adjusted. However, control is never perfect. As water travels, it changes again. Temperature fluctuates. Pipes age. Storage introduces new surfaces. Each stage introduces variability. The chemistry adapts in real time. This creates the early conflict. Water systems are designed for averages. Chemistry reacts to specifics. A slight pH shift here, a mineral spike there. Suddenly reactions accelerate. Pipes corrode faster. Deposits grow thicker. Biological systems strain. What nobody expects is how quickly water remembers. Once conditions favor reaction, it persists. Scale builds layer by layer. Corrosion deepens invisibly. Biofilms establish chemical footholds. The battle becomes entrenched. From the outside, nothing seems wrong. Water still pours from the tap. But inside, chemistry has already chosen momentum. And reversing that momentum is far harder than preventing it. As the battle inside water continues, consequences begin to surface. Not all at once, not dramatically, but steadily with persistence that is hard to reverse. Inside pipes and infrastructure, reactions grow selective. Calcium carbonate crystallizes where flow slows. Layers thicken gradually. Cross-sections narrow. Water pressure drops. Energy demands rise. The system compensates until it cannot. Corrosion follows a similar path. Dissolved oxygen attacks expose metal. Electrons migrate. Protective layers fail. Tiny pits form, then deepen. Leaks appear long after chemistry has done its damage. By the time water escapes, the reaction is old. Biological systems face a more delicate conflict. Water carries ions into every cell. Too much sodium disrupts balance. Too little potassium slows signals. pH shifts change protein shape. Enzymes lose efficiency. The body adapts, but adaptation has limits. This is where tension builds sharply. Because water chemistry rarely announces imbalance, symptoms appear slowly. Infrastructure weakens quietly. Ecosystems shift subtly. Fish disappear before contamination is obvious. Plants absorb metals without visible stress. By the time effects are noticed, chemistry is entrenched. The buildup accelerates with scale. Cities draw water from distant sources. Different mineral profiles mix. Treatment processes adjust imperfectly. Distribution networks age unevenly. Each kilometer introduces new variables. The chemistry grows more complex with distance. Climate adds another layer. Rising temperatures increase reaction speed. Drought concentrates dissolved substances. Floods introduce contaminants suddenly. Water chemistry swings harder and faster than before. Systems designed for stability now face volatility. The paradox becomes clear. Water is essential because it reacts easily, but that same reactivity makes it difficult to control. Every solution introduces new reactions. Every fix shifts balance elsewhere. The battle never ends. It only moves. At this stage, water is no longer neutral. It has history. It carries chemical memory from every surface it touched. Every reaction leaves residue, and that residue shapes what happens next. This is the moment before realization, when control still feels possible, when intervention still seems sufficient. But chemistry is already ahead, waiting for the final conditions to reveal the truth. The climax arrives without drama. It arrives as clarity. Water is not dangerous because it is contaminated. It is dangerous because it is reactive. It carries chemistry wherever it goes. And chemistry always responds to environment, not intention, not design. Once this is understood, the invisible battle makes sense. Water dissolves because it can. It corrodes because it is allowed. It destabilizes systems because balance shifts. Nothing about this is accidental. It is physics playing out patiently. The resolution is not fear. It is respect. When water chemistry is managed, systems endure. When it is ignored, damage accumulates. Infrastructure lasts longer when reactions are anticipated. Health improves when balance is maintained. Ecosystems recover when chemistry stabilizes. Control comes from alignment, not force. Modern relevance makes this unavoidable. Urban growth strains water systems. Aging pipes introduce new reactions. Climate volatility accelerates chemical shifts. The battle inside water grows more intense as demands increase. What once worked quietly now requires constant attention. This reframes responsibility. Clean water is not a product. It is a process, one that must adapt continuously. Testing, adjusting, monitoring, because water never stops responding. When you look at a glass of water now, it feels different, not threatening, but alive with possibility, a system in motion, balanced only as long as conditions allow. Every sip is a negotiation with chemistry. Understanding this changes behavior. It explains why treatment matters, why infrastructure matters, why timing and balance matter. Water rewards care and punishes neglect. The invisible battle inside every glass of water never ends. But it does not need to be won. It only needs to be managed. And once you see that, the world looks clearer, not simpler, but more honest. Sometimes the smallest shift in perspective becomes the beginning of a new future. Then